Okay, welcome to questions on uniform circular motion. The first thing we're asked to do here is to find the little formulas with that little c, and we start off with Vc is equal to 2 pi r over t. Now, this is your velocity formula. However, it is in absolute values because the 2 pi r, what that's actually signifying is the circumference around the circle, and the t is the period. The period, this t, is simply the time it takes to complete a full circle. Now, a lot of times you will see definitions with periods saying period time it takes to complete one cycle. In this case, because we are talking about circular motion, that will be one circle. Another formula we've got here is the acceleration is just equal to v squared over r. Now, again, acceleration is a vector, and so we're going to call that, but we put this in absolute values because the direction of that acceleration is always changing. Now, if we take this velocity, square it, and divide by r, you wind up actually with this formula, 4 pi squared r over t squared. Again, vector with absolute values around the side. So the object spinning in circular motion is going to see a constant change in direction towards the center of the circle, which means this is actually going to show acceleration or a force. Now, in this case, if we've got this object moving in a circle at this point here, it's being pulled towards the center of the circle, but it's actually moving this way. And because it's moving along in this pattern, being pulled towards the center, when it gets to another point, such as here, it's now moving this way, but again, the acceleration is constantly pulling it to the center of the circle. And so you can see how the velocity is constantly changing, but the acceleration is always changing as well. So if we take a look at centripetal force, it really is just the push or pull that causes an object to move in a circle. That causes an object to move in a circle. So let's take a look at our first example. We've got a car that is moving around in a circular track with a radius of 165 meters and takes 20 seconds to complete that. So we're just looking at using that v is equal to 2 pi r over t. I know this is a velocity formula asked for the speed, so really what we're just looking at is we're not going to worry about the direction. The speed is just the magnitude of the velocity. And so plugging in our numbers and typing it in, you wind up with 51.8 meters per second as being the speed of the car as it makes a circular route. If we want to know what the velocity is, again, we need to kind of know, first of all, what direction it's moving, and we're on the very north end of this, and it's moving in a counterclockwise motion, which means when it's down here, it's moving here, right? It's moving around here, and I know my circle is not great, but at the very top, we see the velocity moving in that westerly direction, and because all the numbers are the same, this is 51.8 meters per second going west. Again, 5 seconds later, it will now be heading south. Another 5 seconds later, it will be heading east. And another 5 seconds later, it will actually be heading north as it continually goes around. If we want to take a look at a third example here, a plane making a circle with a radius of 260 meters, or 2.6 times 10 to the 2 meters, with a speed of 93, what is the acceleration? So acceleration, again, v squared over r. We're going to plug in the numbers 93 here, as well as 2.6 times 10 to the 2. And so you wind up with an acceleration of 33 meters per second squared, and that is to the center. Always to the center when you're dealing with examples like this with the acceleration. Now, if we wanted to find the force acting upon this plane, we're looking at the same plane here. We're just now given the mass. And really, we can just use Newton's second law of F is equal to ma. Now, A is equal to v squared over r, or 4 pi squared r over t squared, which means we can also put in mv squared over r, or force is equal to m4 pi squared r over t squared. Now, these centripetal force formulas are not found on the formula sheet. They can be found by taking Newton's second law, which is on a formula sheet, as well as these centripetal acceleration formulas, which also are on your formula sheet. Because we already know what the acceleration, we can just go straight to Newton's second law here, and we're going to take that 4.8 times 10 to the 5, and we're going to multiply that by the 33 meters per second. And what that generates for you is 1.6 times 10 to the 7 newtons, and again, that is to the center. Well, what happens if we don't have the acceleration, Mr. Dunbar? Well, I'm so glad you asked. Here we're asked to find the centripetal force. We got a 1 kilogram object. We've been given a period and a radius. Because we don't have the speed, we could first of all find the speed to find the acceleration, to find the force, or we could just plug that all in together. F equals m a, where a is 4 pi squared r over t squared. And so this is the way that I'm going to solve this here. 1 kilogram, 4 pi squared, radius of 0.6 meters per second, all over 1.25 seconds squared. And this time the force winds up being 15 newtons, and again, that's to the center. It is one that is constantly changing. So give the examples a try, and if you do have any questions, let me know. Thank you.